Hello friends, you all are aware that alternating current can be generated using AC motor, and the movement of electron in alternating current is analogous to the flow of water as shown in this, where it is doing to and fro motion, and in the same way in alternating current electron is doing to and fro motion. So this was the basic idea that at present we are using in order to generate electricity by using windmill, by using nuclear power plant or anything. Just the thing is we have to rotate coil in a magnetic field. So is that sufficient? Because in alternating current we are not getting constant power supply. So which restrict us to use heavy machinery. We cannot use because as it is not getting constant supply, so we would not ensure that it is working at its best level. So we need to use multiple motor in order to power supply. But one thing we can do, in spite of using single coil, we are using multiple coils. So each coil is generating some voltage, and that voltage is given to the source or given to the load. So with that we are ensuring that we are giving somewhat constant power supply to the source. But one thing, in order to do this, we are restricting ourselves of using the common idea of doing calculation with these types of circuit. Here we have to use vectorial idea. The maximum value of voltage is constant, its frequency is constant, but one thing is their instantaneous values are not same. But one question arises, that how many coils we have to use, or can we use infinite number of coils so that we can infinite number of voltages and that we can add up? The thing is, no. It was observed that using 3-phase motor, that means using 3 coils that are rotating in a motor or a magnet is rotating around them, we were getting a good response from that.
Assuming that you have understood that how energy is generated and why 3-phase is used and how we are operating heavy machineries, take this question that why 3 or more than 3 wires are used in transmitting the line. That the answer is clear, because we are using polyphase circuit and especially a 3-phase circuit, and that is the reason why we see these types of pictures in our daily life. Now as we are using 3 coil instead of 1 and a magnet which is moving, so the angle between these 2 coil would be 120 degree. So means there would be a phase difference of 120 degree between the consecutive wave obtained for a particular value. Before moving on to the algebra of 3-phase circuit, try these types of question to brush up your knowledge. This is RC circuit, resistance of 3 ohm, XC is equal to 4 ohm, and 100 volt power supply is given to it. Frequency has not been mentioned because that has been given. If the capacitance would have been mentioned, then there must be frequency so that you can calculate this XC. However, here it is directly given. Then you need to find what is the impedance of this circuit. That is easier one, isn't it? But this impedance I would show you, write it in 3 different ways. What is the amount of current that is going to flow through this circuit? Again 3 ways. What is the power factor of it? More easier way. What would be the wattless current? And many other specifications. So the thing is, you can do it with the rectangular form idea or go with the phasor form. So both are easy, but both must be used at a right time at a right place. So check this first form, that is directly represented by this one, and you would finally find this 5 ohm. But this is not the complete one, because as we are going to deal with multi-phase, so that must be represented in some other form. It could be in rectangular form or a phasor form. So first thing is Z in a rectangular form. In rectangular form, this resistance, what are the resistance values given? Just write it. Like there I was mentioned it as 3 ohm. So 3 plus of, as this is capacitance. In capacitance, you must write it as minus of 4J. That means this will be minus of 4J. Okay, and this can be represented in a phasor form as well. This would be 3, and in this capacitance, current leads the voltage by 90 degrees. So that means, or we can say current would be there, but the resistance or the impedance of this capacitance would be lagging behind the voltage by 90 degrees. So here we have to mention XC, and that has been given as 4. So this is X-axis and this is Y-axis, and Y-axis is being represented by this G vector. Okay, so when to use this one? One more thing you can do. This Z can be represented as 5 at an angle of. This is phasor. This is a polar form representation of it. 5 at an angle of whatever be the resultant of this one. Okay, so whatever the resultant, you mention the angle over there. These things you must use while doing multiplication or divide or doing operation of division. However, whenever you are using plus or minus, then prefer this one over this, because with this one you would be getting an easier answer and less calculation would be required. Now what about the current? Whatever circuit you take, Ohm's law is valid in it. So in the same way, current in this circuit will be voltage or the supply voltage and the total resistance. And resistance is impedance. So means voltage would be 100 and the impedance is 5. So we will get as 20 ampere. So 20 ampere supply will be getting over it. But if I told you that do other forms also, because this would not be a complete one. As we are dealing with polyphase circuit, so we must write its rectangular form, polar form, or a phasor representation. So this can be written as V by Z, where V is the supply voltage. You can write this at angle of 0, as here you will not mention any angle about it. So you can take it as 100 at an angle of 0. That is phasor, that is polar representation of it. And Z, if you are using this in a polar form, try to use this in the same way. This would be at what was that, 5 at an angle of some. This angle you can find using phasor representation, and overall you would get as this. So why not minus 53 at this place? Check this out. If let I equal to V at an angle of theta 1 and Z at an angle of theta 2. So what would be its overall angle? That means here if I am getting 53, what equivalent would have been getting there? It is equal to V by Z at an angle of theta 1 minus theta 2. Simple. And if suppose some quantity is there, X quantity is there, and that quantity is equal to something Y times at an angle of theta 1 into Z times of at angle of theta 2. In this one you will be getting as ZY into at an angle of theta 1 plus theta 2. So in multiplication these two angles would get summed up, and while dividing this is the form. This is just a complex form representation of some quantity, and it's a graphical way of it. Now what about power factor? Power factor initially is equal to cos of psi or theta, you can tell, and that angle is between voltage and a current. But roughly you can take it for easy calculation that whatever X R and XL XC, that resultant would be making some angle with this one. So that is psi. In this case it was 53 degree, minus of 53 degree. Okay, that is just by putting that angle you will find it. And the wattless current is equal to I into sine of psi. Put the value of I, use this sign. You can use phasor representation, rectangular form or polar form, all the three as per your convenience. Now it is okay with simple circuit, but what about if you are using parallel ones? And these types of questions are becoming quite complex if you are going to use the normal idea. So the concept is same, that whatever we are using in DC one, in the AC we are using the same. Like we will find Z1 of this one, Z2 of this, and we will find the effective resistance or effective impedance of this, and then keep on going to the normal way. Now we are aware that 3-phase AC supply is being supplied to each and every house nowadays. But one more important factor is that what type of connection is being given to the house. It is of two types, delta and a star. And depending on the requirement of the power, these two settings can be installed. Phase voltage and phase current is measured across neutral and a phase wire, whereas line voltage and line current is measured across two-phase wire. Star connection is also known as Y-type connection. Its arrangement is as shown. In this, line voltage is √3 times the phase voltage and line current is equal to phase current. In delta connection, phase voltage and line voltage are equal, whereas line current is equal to √3 times the phase current. Real power is the actual power which the load is using. Reactive power is the power which is being dissipated while transferring the power, and the actual power is the total power which is being transferred by a source. Try these two questions and let us know your response in a comment box. Thank you.